Hello, good afternoon. Welcome to the class ECE341, Probability and Stochastic Process. Today we will focus on the topic about how to calculate probability if the random variable is a Gaussian random variable. All right. ECE341. This is for the 8th week, Friday's class. The first one we want to know is any kind of random variable with Gaussian distribution, we can change it to be a standard Gaussian distribution. So things like that. Suppose x be a normal distribution, that means Gaussian distribution, with parameters mu and sigma square. That means the mean of x is a mu and the variance is sigma square. Okay, then let y equal to x minus mu over sigma. Now we let y equal to this. We can have y then satisfy the obey the standard normal distribution. This is standard normal distribution. Standard normal distribution. So firstly, we want to know this. We can show you not so hard because x is a Gaussian like this, right? So we have the PDF of x. There will be 1 over sigma square root of 2 pi times exponential power. The power is negative x minus mu square over 2 sigma square, right? So we have this one. Then we can have, we want to find the things related with y. Then we have this f y of y. That will be the probability of y smaller than or maybe equal to y, right? So this is the definition of CDF. Definition of CDF. Okay, then we calculate this probability. But what do we know is about x, right? So I rewrite this in terms of x. This will be x minus mu over sigma smaller than y. So this is a probability that is x smaller than mu plus sigma y, right? Alright, then we can have what is the probability of this one? We do an integral, right? Integral from negative infinite to mu plus sigma y, and here's a fx dx. Okay, we have this one. Then what is the derivative of it? Here I don't want to calculate to find the final answer. I have this one, that will be fine. Then we have fy of y. There will be derivative of fy of y. Okay, so what it is? You see, for this one we take derivative. This is a integral, upper bound change, right? Upper bound change. So if here is just a single variable, we take derivative, we will get this one. So we have this negative infinite to some ending. I use another letter as like omega fx of x dx. This one take derivative omega. We will have fx of omega. So we have this one. Right? We have this one. So okay, I think this is omega, so I need more space. I can write this as d over d omega fy of y times d omega over dy. I can write it in this way. Then this one we take derivative according to this omega. We consider the whole thing as omega. The result is this one, fx of omega. So this is a fx of omega, where omega is that mu plus sigma y. And omega, this is omega, right? Omega is this one. We take derivative d omega over dy. So I have sigma. So this is a sigma, right? You get this one. Am I good? Let me see. Okay, so what will be this? This is sigma square root of 2 pi 1, right? fx of x is this one. Now fx of omega, it will be e to the negative omega minus mu square over 2 sigma square, right? Omega is now is omega this one, and times sigma. Okay, sigma cancel. I have 1 over square root of 2 pi, and the inside part, omega minus mu over sigma is y, right? You see, omega is this one, so we have omega minus mu over sigma, it is just y. So this part is negative y squared over 2. So e to the negative y squared over 2. Alright. And for standard normal distribution, the PDF will be what? This is a normal distribution, standard normal distribution. Here mu will be 1 and the sigma square should be 1. Mu should be 0 and sigma square should be 1. So it is a square root of 2 pi times sigma. Sigma is 1. So, right, coefficient just like this. Then e to the negative, here should be x minus mu over sigma. X minus mu is 0 over sigma is 1, and 2 times sigma square and square, right? So this is square root of 2 pi in the denominator of the parameter, and the e to the negative x square over 2, right? We have this. You see, the same, just the variable here I use y, right? The same. Okay, so y obey the standard normal distribution. Have this. There. Okay, so based on this, we can do a lot of calculation. We can make things simple. Here, of course, you need know more information about the standard normal distribution. Actually, we have a table about the standard normal distribution. We can table of the N01, right? Table of this. Actually, it is in our textbook. Yeah, I can say like already any kind of probability course, you check the textbook, you can find that table. You can also go online. Let me see, I just viewed before the class. In the page 160, I think it's 160. It was 160. Yeah, it's a table. In section 4.6, make it large. Alright, in section 4.6, this is a Gaussian random variables. Here's the table. Actually, we have two tables. This is one table. This table is for the CDF, the standard normal CDF. So this is the CDF of the standard normal distribution. And the second is a complement. Yeah, this is second. Second one, let me go down. It's a standard normal complementary CDF. So what is the meaning of this one? These two. Let me go to the first one first. Okay, too much. The first table. Yeah, this is first table. This is first table. Let me table 4.2. It is about phi of what? Phi of y. Phi of y. Here is I give the graph. It is N01, right? N01. N01, if we check the PDF, the peak value will be at the place y equal to 0, right? So like this. The world looks like this. And what is CDF? This is CDF. This is CDF. What is CDF? CDF is the integral of the density function. So it's here. The area, the area. If here is y, the area is phi of y. Phi. So if you write in formula, there will be an integral from negative infinite to this y of this fy of. Okay, I still use y with a tilde. Y tilde dy tilde. Right. It's like this. Phi y. This is phi y. Capital phi of y. In this one, or you can show it as a graph. Then the shadow area is the value of phi of y. When y changes, you will have different value. Okay, so this is a phi. So this table, the first table, give us that one. And you can see the table actually it contains two columns or several columns. Each column contains two columns. Like first, one is a z, one is phi z. Okay, z is also fine. In the name of the table, the textbook use phi of y. Here use phi of z. Doesn't matter. It is a phi. Okay. So this z is same with that y. Same with that y. Here z run from 0, then larger one, right? And until the largest z will be here. Let me see. Largest. Okay, it's 3. Sorry. Oh, I can't touch that. Let's disappear. Should be. Oh, okay. Yeah. The largest value should be not exactly 3. It's 2.99, and the probability the phi of y is these. Y is 2.33, 2.99, and the phi of y will be 0.99861. Right. So this is the largest phi. So in the table we only have those value of phi when this y run from 0 to 3. You can say this is 3, right? If you want a larger value, you need a second table. This is second table. It's like a complement. The standard normal complement CDF. Yeah, it says CDF, not exactly CDF. The complement CDF, complementary CDF. This is also two column. One column. I forgot. I can't touch that. Sorry. Coming up. Okay. Also two column. Also two column. So this is a table 4.3. 4.3. This is a Q of Z. It is a complementary T-R-A-R-Y complementary CDF. So what is a Q? I still use this one. This is a PDF. Here's a now Z, then here's a Z. Here's a Z. Actually, this is just Z and Z. And okay, let's use Z here. Then, like here's a Z. You have two column, right? When you have a Z here, what is the value of this one? This one in this area. This area is a Q of Z. It is from this Z to positive infinite, the PDF Fy of y dy. Like this. Z and dz. Sorry, okay. Yeah, this should use just one letter. Okay, just Z. Alright, this one. Okay, so we have two tables. Should be that one and this one. Oh, no. Sorry. Our C. Let me see. Yeah, so just like this. Alright, see like this. So we have two tables. We have two tables. Now how to calculate? I use an example to explain it. Example. Suppose X obey a normal distribution. The mu is 5 and the sigma is 9, like this. That means mu is 5, sigma square is 9. So in other words, Ex is 5 and the variance of X is 9. Okay, so this is X. We want to find the probability of value. I can consider two things. One is X smaller than 7, and another is probability X smaller than 4. Alright, I want to find this value. And second, find probability of X larger than 5, larger than 6, 6.5. Alright, and another is X larger than 4.5. Am I good? Okay, like this. So I have two different kind of probability. One is we want X smaller than something. Second is I want X larger than some value. Right? We want to find the probability. Now how to do it? Okay, we solve it. We solve it by this way. For first one, actually for both. So just let Z equal to X minus. Okay, here I have mu is 5, and the sigma should be 3. Sigma should be 3. Sigma square is 9. Sigma is 3. If you use a notation in the textbook, here should put 3. So 3 is given, and here just use 3 directly. You don't need the square root. Now I have to take square root from 9, I get 3. And then I put 3 here. is x minus 5 over 3. Then z will obey the normal distribution with mean 0 and the variance 1. Do we have this? So for z, we can use the table. Now, for first one, the probability x smaller than 7 is what? I want to rewrite this event in terms of z. So this is a probability of x minus 5 over 3 smaller than 7 minus 5 over 3. Make sense? Yeah, I just, you see, x smaller than 7. X is smaller than 7. And I need this minus 5 over 3. So this part should be z. Okay, so now I have a probability. This probability is z smaller than, what it is? 2 over 3, right? 2 over 3, 0.6667. Okay, we have this. Alright, now we can check the table. 0.667. Now 6. Okay, I can only have this, right? The table just like this. For this table, we have some different version with more accurate. Yeah, if you search online, you can find different versions. Some version of the table is more accurate. But of course, if you use MATLAB to find the value of CDF of normal distribution, use MATLAB, then you can have more accurate values. Here we just use the table. Then you have 0.67. This is a z value. Then take by the table. You know this is a 0.7486. Okay, you get this one. You can put the approximate. Right? Not exactly the same. Approximate. So you have the probability like this. Alright. And we have another similar thing, right? So P of here's x smaller than 4. And what it is? This is a probability of similar x minus 5 over 3 smaller than 4 minus 5 over 3. So this is a probability of z, right? This is a z smaller than what? It's a negative 1 over 3. So this is negative 0.333. Yeah, I only need 2 there. Okay, so z should be a value smaller than 0.33. Well, you check the table, we do not have that. You see? Here all the z values, z should be positive. The smallest value we can have here is 0. We start from z equal to 0, then z increase, right? 0, 0.1, 0.2, and keep going on, and the bottom the z increased to 0.49, and then we're going up to the second 2 columns. Z is 0.5, then 0.51, and increase again, right? But we do not have the value negative 0.333. Now how to do it? Okay, here you need to give a graph. When you have this, you need to give a graph. That will help for the calculate. You need to give a graph. So here, this is a negative 0.33. I'm sorry, it's covered. Okay, we have this, right? Yeah, this is a PDF. You give a graph of the PDF. Then this is a negative 0.333, and you want this part. But you can't find the table. Find it from table. You consider symmetrically. 0.333. So these two parts, they have same area. Right? Symmetrically. The shadow the left side shadow and the right side shadow, they are same area. So we want to know the probability. It is just integral of the density function. That means the area under this PDF. So we want to know this probability. There will be a shadow here. It will be same as this part, right? The same as this part. And what is this part? This part, right? This part. What is this part? We know this part. This is a CDF, phi of z. If here is a z. Okay, so it is what? It is 1 minus phi of 0.333. You got it? Yeah. So you give the graph. This part symmetrically will be as exactly same with this part. They have same here. And this part, you don't know this directly. You cannot have this from the table, but you can have this part from the table. Then the summation should be 1. The total area should be 1. Total area should be 1. Right? The area is the probability. Right? The curve is the density. You do integral, you have this area. That is the probability. Okay, now we have this. And what it is 1 minus, now we can have the table. 0.33 is here. 0.33. We get 1 minus 0.6293. So we have 0.3707. Okay, so we have our probability. Got it? Alright, this is the first one. We want to know the probability of these two. We can calculate by this way. Alright, we check the second one. The first step will be similar. We want to know the probability of about x. We use z. I replace x by x minus that 5 over 3. Then this 0.65 I also need to replace by minus 5 over 3. Right? So this event and this event, they are same event. Right? These two same event. Same event, just one event, right? Same event. But this one, we describe the event by x, in terms of x. Now here, this is z. So we describe this event in terms of z. Z larger than, okay, what it is? This 1.5 over 3. So it is z larger than 0.5. Larger than 0.5. Okay, then what is this? Z obey the normal distribution. I want larger than. Larger than, you need to write it as 1 minus p. Z smaller than, right? Smaller than 0.5. Okay, so this is 1 minus, this is the CDF. Okay, this is a CDF at value 0.5. Okay, in this case we can we find it directly? 0.5. 0.5 is 0.5 should be, is here. 0.5 is here, right? 0.5 is here. Okay, so it is 1 minus 0.69115. This is a 0.3085. Alright, approximate actually. Here is approximate. Yeah. So we have this probability. And similar for x larger than second, larger than 4.5 is 4.5. 4.5, it will be probability. Now I write this x minus 5 over 3, and that one is also 4 to 5 minus 5 over 3. So this is probability of, here's just z larger than what it is. Okay, this is negative 0.5 over 3. I have a negative value again. Negative value, z larger than negative, what it is? This 0.1666, yeah, like this. Alright, we need the table again. But you see, you have a negative value on z. You cannot have table. Oh, before the table, we need to make some check. Okay, I gave a graph. This is a PDF. PDF of z. Z is z by the standard normal distribution, right? Okay, this is PDF. And I have a negative 0.166 is here, and it's larger than, there will be this area. Okay, so actually we always do that. When you have a negative value here, oh sorry, the graph is covered. Yeah. When you have a negative value here for random variable, for standard normal distribution here, you want to calculate the value of the probability. Well, here you have a negative value. Then you give a graph first. Graph of the PDF, and what is this value? Okay, you put it here. Then what is the area? That area is related with your probability, right? So which area do you want? Which area do you want? Now we want this area. You can compare with the previous example. We want areas this one, right? It is z smaller than 0.3, so we use the area like this. Now we want z larger than this negative value. Then we want areas here. Okay, then we do the same thing. Because it's symmetrically, right? So we move these to the other side. This is positive 0.1666, and I have this area. So these two should be same, right? These two areas should be same. These two shadows, they have same area, right? Just reverse the direction, right? As the area, they are same. So what is this area? This area, it is just phi of that 0.166. Okay, so this is a phi of 0.16667, and then you can use the table. You get 0.16. We have 0.16, 0.17, right? 0.17. 0.17, which is 0.5675. Yeah, approximate, actually. Here's approximate. Alright. So we have the value. Any question? I think it's fine, right? Okay. Alright. Now let's consider example. I still use this x obey a normal distribution 5, and okay, I use 100, a different one. Okay, x is this one. Yeah. For this one, now I want to find the probability of x, but x is a value between 6 smaller than x smaller than 8. Probability of 4 smaller than x smaller than 6, and the probability of 1 smaller than x smaller than 5. Not 5. It's 3 or 5. Yeah, we want to find these three. This is more complex than previous example, right? I have two sides. The interval, I have two sides with some values. But the idea is the same. Consider z equal to x minus 5 over 10. Here 5 is the mean of x and 10 is the variance of x. 100 is this. So 10 is the standard deviation of x. Right? So we have this. You let z equal to this one. Consider this one. Z should be a random variable with standard normal distribution. So the probability of 6 smaller than x smaller than a, that will be the probability of, I want to write this event in terms of z. So I need the x minus 10 over minus 5 over 10. Then 6 is also 6 minus 5 over 10, smaller than x minus 5 over 10, and smaller than 8 minus 5 over 10. Alright, so I have, this is the probability 6 minus 5, I get 1 over 10, 0.1. Smaller than, this is just z, right? I'm writing as z. And smaller than this 8 minus 5, I get 3.3. Okay, then we can use the table. I can write this one. This is phi of 0.3 minus phi of 0.1, right? And phi of 0.3, check the table. 0.3 is here, right? 0.3, that is 0.6179, and the minus 0.01 is here. It's 0.5040. Okay, this is 0.1. 6 minus 5, I get 1. 1 minus 0, I get 1. 7 minus 4, I get 3, but 3, and 9 minus 0 is 9. Okay, so this is the probability. Alright. And for second case, the second probability is probability of 4 smaller than x smaller than 6. This will be, I still do the same thing. I need to rewrite this in z, right? In z, so now is a probability. I need a 4 minus 5 over 10, smaller than x minus 5 over 10, and smaller than 6 minus 5 over 10. It's this one. Oh, sorry. Yeah, my camera, document cameras, you can only view the view like this. Okay. We want the probability of these, then write in terms of z. So this is a probability of 4 minus 5 is -1. Yeah, this is why I put these values. I want you in negative case, negative value. What can we do? Smaller than x minus 5 over 10. This is a z, and smaller than, this is a positive 0.1. Okay. Alright, we have negative value again. Now how to do it? You use the table, use the graph first. You have a negative value, you have a positive value, you want this area. Alright. So you need how to do it. This is this one, subtract the minus this one, right? This area is the whole thing, the whole left to negative infinite, and you need to subtract, you need to remove this small piece, right? Remove this small piece. So here's a minus. This one minus this one, and this is phi of, here's a 0.1. So it is. And this one is what? This is a phi of negative 0.1. But this phi of negative 0.1 we cannot calculate it directly. This one can be written as is here, right? Is here, the same. And what it is? This is 1 minus phi of, here's a negative 0.1, but here should be positive 0.1. And 1 minus this. Yeah? Oh, I have these two values, both are 0.1, but they're different. If here's a 0.2, then here will be 0.2, the 0.2. And this 0.1 is just related with this 0.1. Okay, so from here you get this one, and this one is just this. Okay, now we have this result. We have that probability for x, the probability of x between 4 and 6. There will be this one minus this one. Okay, minus this one. Alright, now we use the table to find the value for 0.1, 0.1 z. Oh, I think I gave a wrong table value. As previous one before this, it is this one, right? Here I put this 0.1, I put 0.5040. That should be this value. I use this one. Z is 0.01. Actually, we need this. We need this 53. Okay, sorry. This will be 0.5398. Then this will be what? Is a point. This is still 1, but I need to give 1 for the next. So 0.0 should be A, right? A. But A I can only put 7 because I need 17 minus 9. I have A, and this is 1. Okay, this one. It's this one, not this, not this. All right. It's a point. This value, this probability, this one. It's this one. Okay, and then now this is 0.5398 minus 1 minus 0.5398. This equal to, okay, this minus should be plus, right? So this one plus this one, then minus 1. So okay, I do summation first. 5 I get 1. 3 I get 6, but should be 7, right? Because 990 coming up 1. 9 I have 18 coming up, and 8 I have 16. So it's this one. Okay, and minus this negative 1 here, then minus 1. So this is 0.0796. All right. Okay, so this is the second probability. Yeah. Okay, this is second probability. I want 3. I want 3. So this one is okay. Okay. Now we check the last one from 1 to 4 or 5. Probability of 1 to 4 or 5. We do the same thing. This will be probability of 1 minus 5 over 10 smaller than x minus 5 over 10 smaller than 4 or 5 minus 5 over 10. And then This is the probability is -4/10 and smaller than that z, and smaller than this is -0.5. -0.5 divided by 10. Okay, into this one. Alright, this time we have both bound of this interval is negative, right? I need two negative values. So the same is also similar. You give graph firstly. This is PDF of z. PDF of z. And you have -0.4 to -0.05. You want the areas here, right? You want areas here. Okay, the only thing you want to do is, because it's symmetrically, right? So it is just go to this side. Here's a negative point. Now it's positive 0.05, and this is positive 0.4. So you want area like here, area like here. All right, area like here. Then what it is? This is you just the CDF of these minus CDF of this. So it will be the CDF of z. That is phi. We use the notation in the table. Phi of 0.4 minus phi of 0.05. Right? Okay. Then we can have, we check the table. 0.04 is 05. We done. Okay, it's here. 0.04. 0.04 is 0.6554. And another is 0.05. 0.05 is here. The 5199 minus 0.5199. Okay, now what is the result? We subtract 6 minus 5, I get 1, and 5 minus 1, I get 4, but I need to give 1 for the next, right? 5 minus 1, I get 4, and give 1 for the next, so it's 3 here. Then 15 minus 9, I have 6, but I still need to give 1 for the next. Then 6, 5, give 1 to the next, this is 14. 14 minus 9 is 5. Right, so we have the final answer in this one. Alright, that's all for today. Actually we have two tables, but in this course I don't want to use it. Yeah. So, and in homework, do I have homework? Do I need to use that? I don't think the homework also needed. And in the exam, I will also just use the first table. Okay, first table was enough. This is a just very tiny value. You see, like here, the probability is quite small. It's 10 to -4. Right? Here you have 10 to -7. So it's a very small probability. These kind of things we only needed for some, very accurate calculation. Usually we won't use it. Okay. Alright, that's all for today. See you next time. So this is this is Friday class. Okay, let's see you next week, and we should have a good weekend. Bye bye.